Hello everyone, it's Wilson Souza, and in this video I will be walking through my assignment 4 for my machine learning course. So in this project I will demonstrate how to identify and reduce overfitting when training convolutional neural networking using the CFAR10 dataset. So I will show how overparameterized model leads to of overfitting, and then apply techniques like L2, regularization, dropout, and data augmentation to improve generalization. So I also include training, validation, and test splits, accuracy and loss graph, and explain the number of epochs used to achieve acceptable metrics. So let's get started. So I will explain step by step what I did in this assignment. So first I did import the libraries. As you can see, I did import NumPy, Matplotlib for plotting, and TensorFlow for model building, and learn for dataset splitting. And so those are the libraries that we need for this project. So, and the second, what I did load and normalize CFAR10. Uh, so um, so I did from the data set from Keras, which includes like 60K 32 by 32 color images, so across the 10 categories. So yeah, I normalized the pixels value to between 0 to 1 to help model to train more efficiently. So the next step, what I did train the validation split. As you can see here, I did the validate train and validation split. Um, Training and interset the training and validation subsets, like using like 80 by 80 and 20 ratio. So this helps me to evaluate how well the model performance um, um, training during the training without touching the data set yet. So the next step, what I did build an overfitting model. So no regularization. So here I did create a small convolutional neural network without any regularization. So and then and this basic model is expected to overfit the training data set data, because there is nothing preventing like it from the memorizing patterns, instead learning general features. So yeah, and so the next one that I did compile the training. I did use like 20 compiling training like 20 epochs for speed. um so what I did, I with Adam optimize, as you can see here, I did use Adam optimize to spare sparse like a categorical cross entropy. So then train for 20 epochs. During the training, you see the model overfitting. So as you can see during the training, like you can see the model overfitting is like especially by comparing training and validation metrics. Okay, so the next one, what I did the build and then a model with regularization. So the next step, what I did I use like the new model like L2, so regularization and dropout layers. So this technique is like helps prevent overfitting by reducing the models are relying it on specific neurons, and also like and discouraging like a large weights um, values. So as you can see, I use a ReLU and softmax. There's a dense 64 for ReLU, and then dense 10 for softmax. So the next one I did compile and train the regularization model. So in this part, what I did also use the optimized Adam optimize. So this model is trained for the same number of epochs, the previous one that I did, by comparing both trainings histories. I can demonstrate like how regularization improves generalization. Okay. And then the next one, I did plot the graphics, overfitting, showing like overfitting versus regularized. So I did create two plots. As you can see, here is a two plots, a graph one accuracy and graph two is a loss. So I did create two for each graph compares the overfitting model against the regularized model for each for both training and validation. Okay. So this, and you can see, so the model accuracy and then the loss, as you can see here, you visualize like helps to reduce like the overfitting. Okay. And so the last part, what I did the data augmentation. So the data augmentation is I use Keras image data generator for to apply the data augmentation. So this part, so this I use data, augmented data first, and then I did training the data with augmentation. And this is increase the diversity of training image by applying random transformations like rotation and flipping. So this also helps combat like overfitting and improve the model performance. Okay, so that's my assignment for machine learning course. So this is the last assignment. It's great course. I really enjoy. I learn a lot. So yeah, thanks so much for watching.